Okay, we're going to talk about inverse variation today. So in math, when we talk about variation, we're talking about how something changes. And typically we look at how the independent variable, how we look at the dependent variable, which is y, and how that changes when we make a change in the independent variable, which is x. Sometimes when we increase the independent variable, the dependent variable decreases. This is called inverse variation. Every type of variation equation has a constant in it that is called the constant of variation. So the constant of variation. And in order to write an inverse variation equation, we must know what the constant of variation is. And while this may look intimidating, if we think about this, in the examples we did in class, if we let x be your speed when you're driving, y be the time it takes to get there, k could be the distance you're going. So for instance, if you were traveling to San Antonio, if you change your speed, so if you drive faster, so x becomes bigger, the time it takes to get there gets smaller. They change in the opposite direction. And so if we were trying to do these problems, if we let y vary inversely, so that means if x gets bigger, y gets smaller. So we are told that y equals 6 when x is 15. So using this equation, y equals k divided by x, let's plug in what we know. Y is 6 when x is 15. Now if I want to solve that for k, I simply multiply both sides by my denominator, so that's 15 over 1 times 15 over 1. These 15's cancel, and 6 times 15 is 90. So k equals 90. So now we know what our constant of variation is. It's 90. We need to write the equation that models this situation, which we've got, which is going to be y equals 90 divided by x. And I want to find y when x is 18. So to do that, again, we rewrite the equation. So y equals 90 divided by 18. And if we plug that in our calculators, 90 divided by 15 is 6. So when x equals 18, y equals 6. And let's do another one. Again, we're told that they vary inversely, which that's the key point there. So when x is 6, y is 3. So y equals 3. We don't know k, but we know x is 6. Multiply both sides by 6. The 6 in the denominator cancels with the 6. And k equals 18. So my equation now to find my new x value, we have y equals k, which is 18, over x. Well, we're told what y is. Y is 10. So let's substitute that in. So 10 equals 18 over x. And as you may remember from probably physics, when you've got a problem like this, the easiest way to solve this is just switch these. And the way we switch them, multiply both sides by x, those cancel. Now I have 10x equals 18. Divide both sides by 10, and we get x equals 1.8. So when you've got these two values here, you can actually just switch places. Okay, let's take a look at the next one. So we're going to let y vary inversely as x squared changes. So this changes our equation slightly. It's going to be y equals k divided by x squared. So we know y equals 25. when x equals 2. So x is 2, but it's x squared. So we would rewrite this. We get 25 equals k over 2 squared is 4. To get rid of that 4 in the denominator, I have to multiply both sides of the equation by 4, and I get 100 is k. Write my new equation, which is y equals 100 divided by x squared. My new value is x equals 5. So x has gotten bigger, so I would expect y to get smaller. So x is 5, so let's plug that in. Y equals 100 over 5 squared. And 5 squared is 25. 100 divided by 25 is 4. So y equals 4. That makes sense, hopefully? Okay, number 4. Again, we're going to let y vary inversely with the square root of x. So that tells me my equation is y equals k over the square root of x. And again, we're given our x and y. So 50 equals k over the square root of x, which is 9. The square root of 9 is 3. So now I need to multiply everything by that.